In the first part of this lecture, I talked about the main contours of the history of economic development. Up until about the middle of the 18th century, there was little long-run improvement in living standards. Living standards were relatively uniform across the world and, by today's standards, low. Population growth was also relatively slow. It seems that constraints on the amount of land available and limits on the extent of technological improvement impose constraints on the rate at which population and living standards could increase. Then came the Industrial Revolution. The Industrial Revolution brought gradually accelerating improvement in living standards and, at the same time, significant growth in population. There was also structural change in the organisation of economic activity, from agriculture to industry, and urbanisation, an increasing proportion of the population living in cities. This was all due to a sustained period of technological advance. That period of technological advance started off in England and spread relatively quickly to other parts of Western Europe and to the offshoots of Western Europe. But as we sit here 250 years after the start of the Industrial Revolution, there are still countries that haven't caught up with England and the other advanced countries in the world. This is the phenomenon that I called the Great Divergence. The reason for giving this brief reiteration of the contours of economic development is to make the point, again, that I think the really big question in the history of economic development is, why are some countries rich and some countries poor? In this part of the lecture and the next part, I'm going to talk about two frameworks for thinking about trying to answer that question. In this part of the lecture, I'll talk about technology, and in the next part of the lecture, I'll talk about what I'll refer to as fundamental determinants or deep drivers of economic development. In this part of the lecture, I'm going to be talking about technology. Being a rich or poor country is about the amount of output of goods and services that you produce per member of the population. So one place to start thinking about the sources of difference between rich and poor countries is thinking about the amount they produce and how they come to produce differing amounts of output. For an economist thinking about output, the starting place is usually a stylised model of production, represented sort of one way of thinking about that on this slide. So on the left-hand side, you have what we call inputs, things like land, capital and labour. Those inputs are going to be transformed and ultimately produce some type of output. So for example, if we were thinking about production of wheat, then we know that we'd need land, we'd need workers on the farm, and we'd need capital. Perhaps if we're talking about a period a few hundred years ago, it might be something like a horse-drawn plough. And those inputs are going to be used to produce output through something that I've labelled here a production process. The production process is all the decisions that have to be made about how to combine the inputs together to produce output. So that would involve deciding things like how much of each of the inputs you would want to use, what way you should plough the soil, what time of year you should plough the soil, when you should plant the seeds. A whole set of decisions like that will determine the amount of output that's produced. Another aspect of the model of production that I want to talk about is the idea that you could use different methods of production to produce the same amount of output. So if we're still thinking about the example of wheat, you could have one method of production where our capital is the horse and plough. You could have another much more modern method of production where the capital that you're going to use is diesel-powered machinery that's going to be used to plough the soil, put the seeds in, and eventually to harvest the wheat. And I'm thinking of these as different methods of production in the sense that they involve quite different decisions that have to be made about the production process. Other examples of alternative methods of production might be in mining, where you could have an old method such as this, pan mining for gold, or a new method which uses open cut mines and expensive capital equipment to do the mining. How does technology come into the picture? Well, I'm going to think of technology as being the knowledge we have about how to produce. And technological change I'm going to think of as advances in knowledge of how to produce that allow society to get a larger output from its available inputs. So technological change is about working out ways in which we can produce more from our available inputs. We can think about sort of sources of technological change in terms of the model of production that I just described. One source of technological change would be if we found a new method of production that allowed us to produce more output from the inputs we have available. That's often referred to as macro invention. The other possibility is that we have a particular method of production and then we refine that method of production in a way that allows us to increase the amount of output that we get from our inputs, and that's often referred to as micro-invention. An example of macro-invention or micro-invention might be that in banks we might have computers replace humans as a way of doing adding up of numbers in bank accounts. The micro-invention might be then if we made improvements to the software which we're using with the computers that allows us to do that adding up of the numbers using a computer quickly, or more and more quickly. We can use the model of production and this idea of technology to think about the question of why some countries are rich and some countries are poor. And the way we do that is using a method called growth accounting. What growth accounting does is that it decomposes differences in GDP per capita between countries into components that are due to, first of all, differences in the amount of inputs used. So this is what's referred to as factor accumulation, and differences in the transformation of inputs into output, what's referred to as productivity or efficiency. So if you think back to the wheat example, suppose we knew that there were two countries, one of which produced more wheat than another. Well, there's two possible reasons why that could be happening. One reason is that both the countries could be using exactly the same way of transforming inputs into output, but one of the countries might just have more land or more workers or more capital equipment to use to produce wheat, which would explain why its output of wheat was higher. Or we could think of two countries, both of which have exactly the same amount of land, the amount of workers and the amount of capital that they can apply to produce wheat, but one of them just has a better understanding of how to combine those inputs together to produce output of wheat. So they're better at knowing a way to plough, they're better at knowing what time of year to put the seeds into the soil, and so on. And so they would have higher output than we would say because of greater productivity or efficiency. They're making better use of the resources they have available. There's two ways in which we can usually think of applying growth accounting. That is dividing up differences in GDP per capita between factor accumulation and efficiency. One of them is to focus just on labour as the measure of inputs or factor accumulation that we're going to think of as being a source of difference in inputs between countries. In that case, the efficiency measure then becomes labour productivity. So, in other words, one way that we can do decomposition through growth accounting is we can say, look, countries could differ because they're applying different amounts of labour, or they could differ because they differ in the productivity of labour. The other method is to count both labour and capital and potentially some other inputs in what you're thinking of as factor accumulation. And so then it's differences in labour, differences in capital and those other inputs that we think of as representing differences in factor accumulation. The efficiency measure then is something that we refer to as total factor productivity. The effect of the transformation of inputs on output once we've controlled for the amount of labour and capital and other inputs that countries are using. Now, an important aspect of doing growth accounting is how you measure labour and capital. This can make a difference to how much you end up attributing to differences in factor accumulation or efficiency. For example, if you think about labour, one way of measuring labour would just be to look at the number of workers in each of two countries. Another possibility, which would be better if you thought that, for example, average work hours differed between the two countries, would be to look at the total amount of hours worked in each of the two countries. Also, we know that skill is likely to affect the amount of output that workers or labour can produce. So we might want to also adjust our measure of labour for the education attainment or skill of the workers in the population. For example, attaching a higher weight to workers with higher level of education attainment. And these are all issues that researchers who use growth accounting methods worry about in trying to understand the relative effects of factor accumulation efficiency on cross-country differences in GDP per capita. Now, one important point is about interpreting the findings from growth accounting decomposition analysis. It's possible to treat cross-country differences in total factor productivity as largely reflecting differences in technologies used and the efficiency with which technologies are applied in production process. So we're going to think in the rest of this part of the lecture as factor accumulation representing differences between countries in the amount of inputs that they can apply to production, and we're going to think of differences in TFP as reflecting differences in technology or the efficiency with which technologies are applied between countries. And so the more that TFP differences between countries are important, the more that it's telling us that differences in technology and the way they're used is part of the story about differences between rich and poor countries. So what is the evidence? Well, one sort of first piece of evidence to present is just to show you that there is a strong correlation between TFP and GDP per capita. So this takes some data from the early 1990s and, from the mid-1980s and looks at the relationship between GDP per worker relative to the USA and total factor productivity relative to the USA. So the USA is here it's one on each of the two measures, and all the other dots represent all other countries relative to the US on total factor productivity and GDP. And you can see that basically they lie along this, quite close to this positively sloped line, which is telling you that total factor productivity is quite strongly related to GDP per worker in different countries around the world. How much of the variation in GDP per capita is explained by total factor productivity has been the source of some debate over the past couple of decades. There are some studies that have claimed that all the difference in GDP per capita is due to TFP differences. Some have argued that it's all to do with factor accumulation. I think the truth probably lies in between, and this quote from Chang Tai-Tsie and Peter Klenow in a recent survey of the literature on growth accounting, I think puts it nicely. They say there's a broad consensus that differences in human capital account for about 10 to 30% of country income differences. Physical capital accounts for 20% of country income differences, and total factor productivity is likely to be the biggest part of the story, accounting for about 50 to 70% of country income differences. So differences in total factor productivity, how technology is used and applied, are an important part of the story about cross-country income differences. It's also necessary to take into account that when you do growth accounting, it may to some degree understate the importance of efficiency or total factor productivity, in that accumulation of capital, both human capital, education and physical capital, is likely to be driven by efficiency. So countries which are highly efficient are likely to have the greatest incentives for workers to acquire human capital and for entrepreneurs to create physical capital. And this quote that I've taken from William Easterly and Ross Levine is making that point. It says, factor movement towards the richest countries reinforces the concentration of economic activity. Each factor of production flows to where it's already abundant. So, for example, we know that capital flows mainly to rich countries. In 1990, the richest 20% of the world received 92% of gross portfolio capital flows, whereas the poorest 20% received just 0.7%. So TFP on its own account is important, but it also drives capital, physical and human capital accumulation to some degree. So we should think of differences in efficiency as being an important driver of differences in countries' GDP, whether they're rich or poor. And so here I've just sort of given a conclusion that I think comes from this review of the evidence, that there's a large and critical role for differences in how countries produce, in their technologies and how they use them, in explaining cross-country differences in economic development. So in the rest of this part of the lecture, I just want to pursue this theme of technology diffusion a little bit further. If we think that technology differences matter for whether countries are rich or poor, then an important question is, why does a country, or how does a country come to acquire technology? There's two main ways. One, you can home grow improvements in knowledge of how to produce, or you can take technology from countries that you observe are using better technologies than you are. Now, for countries which are the leaders who are currently at the frontiers of technological development, then homegrown improvements in knowledge of how to produce are going to be the most important way in which they can acquire new technology. But for many countries around the world, and in particular for countries that are a long way behind the frontier, the most important way in which they're likely to acquire technology is by taking that technology, acquiring that technology from countries that they observe are using better technologies. So if we think that economic development is, to at least some degree, about differences in technology, and if we think that the main way that poor countries could be acquiring better technology is by taking that technology from rich countries, then it really means that an important question is, why isn't technology diffusing from rich countries to poor countries? And this is summed up in this quote by Richard Easterlin, who wrote an article back in the early 1980s, Why Isn't the Whole World Developed? Easterlin said, it seems reasonable to conclude that the question of explaining differential technological change among nations in the modern period is a matter chiefly of explaining the limited diffusion of a common technology. So Easterlin is really making the same point, that there are rich countries that have advanced technologies, there are countries that behind that could be taking those technologies from the rich countries but don't seem to have done so. And so then the question becomes, why not? In this graph, I've shown data that come from a recent study by Diego Coman and Bart Objan. They looked at data on the diffusion of 15 technologies across 166 countries over the past 2 centuries. In this graph, I've shown the USA, Great Britain, Japan, Asian tigers, and sub-Saharan Africa. On the horizontal axis, I've started out with technology 1, which is steam and motor ships, and gone through to technology 15, which is the internet. And a dot corresponding to a particular point shows the adoption lag for a particular country in taking up that technology. So if we look here, we see that the USA and Great Britain, they adopted steam and motor ships 100 years before the average, whereas the Asian tigers and sub-Saharan Africa adopted steam and motor ships about 40 to 60 years after. One thing you can see from this graph is that as time goes on, the dispersion in the time of adoption becomes less. So when we get down to the internet today, we see that all of these countries and regions adopted the internet at pretty much the same time. The other really important point for my purposes is to say the dots for particular countries or regions all seem to be above or below the line, which is the average of 0. So for example, Great Britain, all of its observations pretty much are below the line. The United States, all of the observations are below the line. That tells us the United States and Great Britain have consistently been quick to adopt new technologies. Whereas if we look at the Asian tigers and sub-Saharan Africa, their observations tend to be above the line. That tells us that they have been consistently slow to adopt new technologies. So this is a little bit more evidence about the idea that economic development may be to do with technology, and in this case technology diffusion, that there are consistent patterns in the way that regions or countries adopt new technologies. In the next part of the lecture I'll go on to think about some reasons why that might be the case.